In this chapter, you'll learn what a program is and how to write a few simple programs. Writing programs is a specialized aspect of using a computer. Remember, you don't have to know how to program to use your Apple III. If you do, however, you can increase your productivity and enjoyment of your personal computer. So we'll point you in a programming direction. If you find that you enjoyed and want to learn more, you'll certainly want to explore the various languages available for your Apple III. Actually, much of the application software available for your Apple III is written in Pascal. But in order to write programs in Pascal, you'll need some additional software that doesn't come standard with every Apple III. In fact, another language designed for your Apple III, Business Basic, requires a software disk. We can't be sure whether you have the Business Basic software or not, so we're going to do some exercises in standard AppleSoft Basic that was designed for the Apple II. All Apple III users have AppleSoft Basic software on their emulation disk. So find the Apple II emulation disk and boot it. After the disk stops whirring and your screen shows this display, hit the return key once. At this point, the program is asking you to insert an Apple II disk and press Escape. We're not going to use a disk for this chapter. In fact, all we're using the emulate disk for now is to take advantage of the language software available on this disk. So by pressing the reset key only, you'll get the program to emulate an Apple II personal computer with AppleSoft Basic loaded in RAM. Do not hold the control key when you press reset. Just press the reset key. Go ahead and do it now. At this point, you should be seeing a flashing cursor at the lower left corner of the screen and a bracket. That bracket is called a prompt character and shows you the line where you will be typing first. Essentially, a program is a logical and sequential list of orders you give to a computer to tell it how you want it to do what you want done. The important thing to remember about writing new programs is to understand and plan each and every step that must be done. Your computer will do exactly what you program it to do, nothing more. You must tell it all it needs to know to accomplish your task. If you leave out even the smallest instruction, your computer will not run a program correctly. Remember, your computer is really very dumb until you tell it what it needs to know to operate. You're going to write a few programs now, so let's start with a clean screen. At the cursor, type the word Home and hit the return key. Your screen should have cleared and the cursor and prompt character moved to the upper left corner of the screen. The word Home is a so-called reserved word. It is one of the many specific English words that your language has programmed in. These reserved words are frequently used commands that would take many more keystrokes to execute. Rather than requiring you to type in several lines of instructions to clear the screen, move the cursor to the leftmost edge and then to the topmost edge. Home simply does it all for you. Now type the word New, then press Return. New is another reserved word that tells your computer that the next set of instructions it receives from the keyboard will be a new program and that it should forget any previous programs. Typing the word New at the prompt clears the memory. Then type this exactly as it appears. 10, space, print, spacebar, shift quotation mark, H, E, L, L, O, shift quotation mark. Then press the return key. Be sure you use the double quotation mark sign and not the apostrophe. When you enclose words inside of quotation marks, the program will, later, print out what you have written within the quotation marks exactly as you have written it. Now type 20, spacebar, print, spacebar, shift quotation mark, goodbye, shift quotation mark. Then press the return key. Now type 30, spacebar, end, return. Now type list, return. There is a new list of what you have just entered. Now type Run, Return. Your Apple followed your instructions and printed exactly what it was told to print. Nothing less, nothing more. Now type List, Return. Let's examine the program. The number 10, number 20, and number 30 are called line numbers. They tell your computer the order in which commands should be executed. It's a common programming practice to leave blocks of numbers between line numbers. Later, with more complex programs, you might want to add one or more commands in the middle of a program between two or more lines. For example, type the line 15, space, print, space, shift, quotation mark, eat, E-A-T, shift, quotation mark, return. Now type list, return. Notice how the line number 15 has been added in the proper order to your list. Now type run, return. And the program was executed exactly as you modified it without rewriting all the old lines. Incidentally, the word print, as we've used it here, means to output to a device. In this case, your monitor screen. It doesn't necessarily mean to print only on your printer. Remember, too, if you make a typing error, move the cursor back over your mistake and retype to the end of the line. If you've already pressed return and realize you've made a mistake, as we did when we typed the word eat, simply retype the line number and the rest of the line correctly. The new correct line will replace the old incorrect line in memory. Now type home, return. Now type new, return. Then 10, space bar, print, space bar, 5 plus 4, return. Then type 20, space bar, end, return. Then type run, return. Notice that the program added the 5 and 4 and printed only the total. That's a simple example of an arithmetic function already available in a language program. It might be of interest to you to know that language software has certain functions already programmed and ready for your use. The addition you just did is available in AppleSoft Basic. Other operations most basic language versions offer are subtraction, multiplication, division, and raising to a power. Now let's get rid of that program and do another one. Type new, return. Then type 10, space bar, print, space bar, shift quotation mark, I, love, space bar, shift quotation mark, semicolon, return. Then type 30, space bar, go to, 10, return. Then type 20, space bar, print, space bar, shift, quotation mark, U, shift, quotation mark, return. Now type list, return. Notice what happened. The list command automatically arranged each line in your program in the proper numerical order. You will find that a very useful feature as you learn to write longer and longer programs. Now type run, return. Don't panic. Just type a Control-C to stop the program. That go-to command on line 30 caused a loop to be created. Your Apple merely did what it was told, went back to line 10 and did it again, and again, and again, until you stopped it. Let's take a moment and examine a few of the things we just did. First and foremost, you wrote 3 small programs and then ran them. Each time you wanted to start a new program, you typed new. That command told your computer to forget forever any previous program in memory and lets you start a complete new one. You then assigned a number to each line. This told your computer in what order you wanted the execution to take place. You also asked your Apple to list the program you had just typed in. When it did list, it automatically placed any lines that were typed out of sequence into the proper numerical sequence that you desired, since you gave each line a number. Of course, you asked the computer to run your new program. The last program had what's called a loop in it. When the program came to the line that had a go to command, it looped back to the previous line. The loop just kept going round and round until you interrupted the program with the Control-C command. When you did the Control-C command, your Apple told you where it stopped. You used several reserved words when you were programming: run, list, go to, new, and print. There are many other reserved words that are available to help make programming faster and easier to understand. However, because some words are reserved for certain functions and commands, you must be careful you don't use them out of context when you're programming. A complete list of the reserved words for a particular language usually comes with a language reference manual when you purchase that language program. Let's try a new program. Take the cursor home by typing home, return, and clear the memory for this new program by typing new, then pressing return. Here's our next program. Type 10 space n space equal sign space value 1 return. Then type 20 space n space equal sign space n space shift plus sign space 1 return. Next line, type 30 space print space n return. Then type 40 space go to space 20 return. Now list your program. Now run your program. Remember how to stop it? Control-C will do it. In this program, you assigned a variable number to a letter, then told your computer to print the number that represented the letter. You also told it to increase the value of the number by 1 each time it looped back to line 20. In computer programming, any value, number, or letter on the right of the equal sign gets put into what's on the left of the equal sign. Don't let your previous experience with algebra fool you here. We'll do one more, somewhat complicated program for now. Follow very carefully and type in each line exactly as we show it. If you make a mistake on a line, simply retype that line's number and retype the line correctly. Ready? Here goes. Clear your screen. Type new, return. Now type 10 space input I N P U T space shift quotation mark. What is your name? Shift question mark space shift quotation mark semicolon A shift $, return. Check it against ours. Now type 20 space input space shift quotation mark, name an animal, shift question mark space shift quotation mark semicolon B shift $, return. Is it exactly like this one? Then type 30, space, print, space, shift quotation mark, hello, comma, space, shift quotation mark, semicolon, A, shift $, semicolon, shift quotation mark, space, you look like a, space, shift quotation mark, semicolon, B, shift $, return. Last line, type 40, space, N, E, N, D, return. Before you run this program, list it. Type list, return. Check your list against ours one last time. Now run it. Type run, return. Follow the directions you've programmed in and answer the questions as they come up. That's the last program we'll do here. It's more complex than the earlier ones, but by programming standards, it contains a lot of common functions and commands that you will soon discover come easy to you once you become better acquainted with basic programming. That's what computer programming is all about. Step-by-step instructions on how to solve a problem in logical sequences written in computer language. Let's take a moment and examine a few of the things we just did. Generally, a program has 4 parts. Part 1, initialization. Part 2, the body. Part 3, the output. And Part 4, the conclusion. During Part 1, the initialization, constant and variables are defined and given starting values. Part 2, the body, is where the work is done. In this part, the program will ask for data from an input device such as your keyboard. It will then process that new data with respect to the set of constant and variable values that were programmed in the first step. The program will make any decisions that it has been programmed to make. It will then send the results of that computation to an output device such as your display screen or a printer. This is the third part or output stage of the program. Part 4, the conclusion, is just that, the end of the program. And so you see, we're right back to where we started in Chapter 2. The computer fetches instructions from memory, performs those instructions, adds information if required from input devices, and displays or transmits the results of that process through output devices. The speed of that process, combined with a number of steps the computer can do with one batch of information in its memory at a given time, determines how powerful your computer is. Just remember, the huge mainframes and your micro all do the same thing over and over and over again. You are always the master, and you're always in control. In this chapter, we've worked with a version of the programming language called AppleSoft BASIC, originally developed for the Apple II. A more powerful version of BASIC called Business BASIC is available for your Apple III. If you're interested in programming, you can get more information from your dealer. Also, a somewhat different and very powerful language called Pascal is available. Pascal is a very efficient language in that it has an operating system of its own to compress and condense instructions into a more direct form of machine and assembly language. It allows very long and complex programs to be stored in a minimum amount of memory space. Programming can be extremely complicated, but not necessarily difficult once you've learned the language. Essentially, it's very straightforward and logical. If you feel that you would like to go further with programming, get a hold of any of the currently available programming manuals, a language software program for your Apple III, and have at it. It can only be learned by doing. But always keep in mind, you don't have to know how to program to get full value from your personal computer. Other people are writing programs every day that will extend the usefulness of your computer for years to come. You now have learned all you need for years of rewarding and interesting interaction with your personal computer.